There's a lot of room for error for this question. A lot of people make mistakes with confusing. Basically, they confuse the base of this 30, 60, 90 triangle for the base of the whole equilateral triangle. So let's just start this off and keep that in mind. Okay, so it says the figure above shows a regular hexagon with side lengths of A and a square with side lengths of A. So basically it's saying that this side length of A here is in common. It's going to be the same length for this hexagon and for the square. Okay, if the area of the hexagon is 384 times root 3 square inches, what is the area in square inches of the square? Okay, so since it's a regular hexagon, we can divide it into 6 equilateral triangles. So we can divide the total area of the hexagon by 6, and that will give us the area of just one of these equilateral triangles here. So that's what I've done here. And then this gives us that the area of one of the triangles is 64 root 3. Remember that the area of a triangle formula is half base times height. So this B here refers to the base of the full equilateral triangle, but we're going to have to use the fact that an equilateral triangle can be divided into two 30, 60, 90 triangles in order to set up what the base and the height are in terms of a constant. In this case, our constant is x. Don't get x confused with a. A is 2x because you're going to have two of these x values here to make up a. That's a common point of confusion. Okay, so we have our 30, 60, 90 triangle ratios in the front of every math section. I've just reproduced that here, showing that every equilateral triangle, when it's bisected by the altitude, the height, it makes two 30, 60, 90 triangles. So we have that here. Okay, so to express the base, we're going to say that the base of the 30, 60, 90 triangle here is x. So the base of the full equilateral triangle is going to be 2x. So that's what I have here, because this base here refers to the base of the full equilateral triangle. So half 2x times the height is x root 3, and that's for the whole equilateral triangle. So our area in terms of x is x squared, because these 2's cancel. We get x squared times root 3. And that we can set equal to 64 root 3 because we figured out that that is the area of each individual equilateral triangle earlier. Now we're just solving for x. So we can cancel these root 3's. Then we get 64 equals x squared. And we get 8 equals x. Luckily, they don't offer 64 as an answer choice here. I think that would be a common mistake. The 8 refers to the base of the 30, 60, 90 triangle only. We need the base of the complete equilateral triangle here because that is the shared side with the square. So we need 8 times 2. Each side of the square is therefore 16 units, 16 square inches. So the area in square inches of the square is going to be 16 times 16, which is 256.